Something is shifting in the world of artificial intelligence. A profound change is underway, moving faster than anyone expected. You can feel it. It's like the quiet hum before a big storm, or the opening credits of a movie you know is going to be a blockbuster. We all remember the big bang of ChatGPT, right? Overnight, the world woke up to the power of large language models. Suddenly, AI wasn't just for tech nerds in basements, it was writing our emails, our poems, even our breakup texts. It learned to talk, and it got very, very good at it. But now, the smartest people in the room, people like Yann LeCun and Jensen Huang at NVIDIA, are saying that's just the beginning. They're pointing to a new frontier, a next phase, where AI doesn't just talk, it does. This isn't a small update, this is a fundamental change in direction. The AI we've gotten used to lives on our screens. It processes text, generates images, and exists purely in the digital realm, but the next wave is stepping off the screen and into our world. It's the difference between an AI that can write an email about a package delivery, and an AI that can physically find that package, pick it up and deliver it to your door. This is embodied AI, an intelligence that can perceive, interact with, and learn from the physical environment. Imagine an intelligence that understands not just the word apple, but its weight, its crunch, its color, even how it rolls. An intelligence that has a physical intuition for the world, just like we do. To understand where AI is headed, we first need to grasp a fundamental shift in its core architecture. Let's break this down. Most of the AI that has wowed us, like ChatGPT, is built on a simple but powerful principle. It predicts the next word in a sentence. It has read a massive chunk of the internet, developing an incredible mastery of language, style, and information. Through statistical patterns, it knows the cat sat on the likely ends with Matt. But this mastery has a crucial blind spot. The real world doesn't work like that. It isn't a sequence of words, it's a cascade of cause and effect, governed by the laws of physics. If a glass teeters on an edge, you don't just predict a word, you anticipate a future. You understand gravity, momentum, the fragility of glass and the resulting mess. You have an intuitive, predictive mental model of the world. That's what researchers are now building for AI, world models. Think of it as an internal simulation, a virtual sandbox where the AI can run experiments. It learns from watching video, from processing raw sensor data, and from physically interacting with the world. Through this process, it learns the implicit rules of our reality, not just of language, but of physics. It learns that objects persist even when hidden, that they can't pass through each other, that a bowling ball dropped on your foot is a very bad idea. It's the fundamental difference between reading a million books about swimming and actually jumping in the water. AI pioneer Yann LeCun argues that large language model architectures, for all their power, won't cut it for interacting with the real world, where the number of possible futures is basically infinite. In text, the choices for the next word are vast but ultimately finite. In video, or reality, the plausible futures branch out endlessly. In the next second, someone could walk into the frame, a bird could fly by, the wind could rustle a leaf, a car could drive past. Each event changes what happens next. To handle this, we must shift from purely generative AI to predictive architectures that can reason about and plan for a multitude of possible futures. For years, robots were sci-fi stars, but real life was a letdown. We built amazing single-task machines. Weld, repeat, perfection. Ask that same robot to make coffee? Blank stare. Hardware wasn't the blocker. The brain was. Strong, yes. Smart and adaptable, not yet. Physical AI with a world model changes that. It learns by watching, stacking dishes, folding laundry, organizing a shelf. Its internal model encodes weight, flexibility, friction. Then it generalizes to new but similar tasks. That's how we get a truly useful helper. One that adapts to the chaos of real homes, not just sterile floors. Investors are waking up to the potential. NVIDIA's Jensen Huang talks about embodied AI infrastructure and next-gen data centers to power physical systems. Robotics is the next major platform, potentially bigger than the internet, maybe even mobile. If you think the physical world is complex, look inside us. Biology spans molecules, cells, tissues, and organs, a universe of staggering complexity. At every level, intricate systems are at play. Proteins form complex machinery, interacting in vast networks called pathways. These pathways govern cellular behaviors, which ultimately determine our physical traits and disease risks. Our phenotype. It's a dynamic, multi-scale system that has been incredibly difficult to model, a biological dark matter that has hidden the root causes of disease. Here, language-based AI hits a wall. As J.P. Vert says, LLMs won't cure cancer. Cancer doesn't speak English. To make progress, AI must learn biology's native language, the language of genes, proteins, and their countless interactions. This is the power of world models in biology. They connect these scales, from a single molecule, to a cell, to a whole person. Today, AI can already design novel proteins that have never existed before. From a single biopsy image, these models can infer the molecular activity happening inside cells. This allows us to predict which patients will respond to a specific therapy, creating a direct path to personalized medicine. Imagine a pipeline. A patient's unique biological data is fed into a model, which then simulates their likely response to a drug, guiding doctors to the most effective treatment from the start. These powerful tools are already being deployed in labs and pharmaceutical companies. It's a quieter revolution, happening mostly behind the scenes, but its impact on our health could be the most profound of all. We're shifting medicine from being reactive to being predictive, from a process of trial and error to one of rational design. We are learning how to design cures, not just hope to discover them by chance. While consumer robots may still be 3 to 5 years away, this biological AI is already here. This is the next paradigm in medicine, and it all starts with building world models of life itself. What do we need to build physical AI? It's not a new app, it's a whole new stack. First, data, not Wikipedia or Reddit, but high-quality video, sensor streams, 3D scans, and biological measurements. Collecting and curating this is massive and foundational. Next, compute. Training world models is astronomical. NVIDIA and others build the engines, GPUs, and accelerators. For physical AI, we'll need efficient, specialized systems at the edge. Then, model architectures. LLM tricks don't translate to infinite futures. Enter joint embedding predictive architectures to reason and plan, and we need better sensors and actuators to match. This is AI plus robotics, plus CS, plus materials, plus biology. Why are startups leading this charge? Focus and freedom. Big orgs chase LLMs, attention and budgets follow one trench. Pioneers like Yann LeCun and J.P. Vert stepped out to move faster. Startups can take risks, iterate, and ship. Paris is emerging, with deep math, engineering, and bio-talent. We're on the edge of a new era, equal parts awe and anxiety. The promise is immense. Robots can take the dangerous and the dull, freeing us for creative, meaningful work. In medicine, we could tackle diseases long thought unbeatable. This is about improving the human condition, energy, health, manufacturing. But physical AI brings new risks. A text mistake is odd. A robot mistake can break things, or worse. In healthcare, errors are life or death. Safety, testing, and alignment must be core, not afterthoughts. Decisions on funding, standards, and priorities set our course for decades. Unlike the overnight feel of ChatGPT, physical AI will roll out gradually, factories and warehouses, labs, then the home. This gives us time to learn, adapt, and prepare. We've finished the prologue. The next chapter, world models and physical AI, will be more dramatic. We can't be spectators. Stay curious. Ask hard questions. Support tech that's powerful, safe, reliable, and benefits everyone.